so delighted to welcome you all here this evening, both our in-person audience and indeed our online audience. And we have had a wonderful turnout, both online and in person. So thank you so much for being here tonight, particularly those of you who've put up with the rain, so thank you. Tonight's talk, Restoring the Flatiron Building, is part of the Labour, Literature and Landmark Lecture Series for 2024. Now, we are so fortunate tonight to have Howard L. Zimmerman, founder of Howard L. Zimmerman Architects and Engineers, and his colleague, Alexei Tajzler, our aide, who is the director. And they're both here, as you know, to talk about the magnificent restoration they have done on one of New York City's most iconic buildings, of course, the Flatiron Building. I also will take this opportunity to thank Alora and Rosie in HLZAE's marketing department for all their help. For those of you less familiar with the General Society, a brief introduction. The General Society of Mechanics and Tradesmen of the City of New York was founded in 1785, that is 239 years ago. Today, our organization continues to serve and improve the quality of life for the people of the City of New York through our various educational and cultural programs. These include our tuition-free Mechanics Institute, our John M. Mossman Lock Museum, which you are welcome, our in-person audience is welcome to visit after tonight's talk. Our mechanics, our General Society Library, of which, of course, we're standing in this evening. And finally, our lecture series, a lecture series that originally started in 1838. Before I provide some background on Zimmerman, again, a quick reminder to mute your phones. HLZAE is a full-service architectural and engineering firm that specializes in the exterior and interior restoration, preservation, and alteration of existing buildings, including their mechanical, electrical, and structural systems. The firm's team offers expertise in the adaptive reuse of existing buildings, exterior envelope, forensic investigation, MEP, and new construction consulting services. In addition, HLZAE works closely with the New York City's Landmarks Preservation Commission, LPC, and New York State's Historic Preservation Office to protect and revitalize New York City structures of historical significance. Notable projects include the extensive exterior restoration of the Plaza Hotel and Riverside Church. Zimmerman also captured 3 awards in an annual design competition hosted by the New York chapter of American Registered Architects. The firm was recognized for excellence in the category of building rehabilitation for projects at 6 Harrison Street, 55 White Street, and 40 Litzenberg Street. All 3 buildings underwent extensive facade, roof, window, and precise exterior detail restoration work in varying degrees. It's now my absolute huge pleasure to introduce to you Howard Zimmerman and Alexei Tajzler. Thank you.
Thank you, everyone. Thank you, Karen, for that lovely and glowing introduction. You killed about 3 slides of mine, but that's okay. Angelo for helping. And I just would like to thank the General Society of Mechanical and Tradesmen of the City of New York, how fitting their motto is for tonight, or their motto in general, by hammer and hand, all arts do stand. I just find it very appropriate with the lecture that we're going to talk about. Is there feedback here?
Yes, we're addressing.
Okay. Anyway, I think it's great that they prepared this room and put up pipe scaffold in honor of our lecture to get better in the mood. So here we go. By the way, could I ask with a show of hands what the makeup of the audience is? Architects? engineers, tradesmen, generally interested historical buffs? Okay, great, got it. Thank you very much. Sorry, so Karen really explained this slide, so I'll just go in here. I ask you to just remember this penthouse for later. I have a story to tell about that. So the Flatiron Building was completed in 1902, has become an iconic symbol of New York City's architectural landscape. Renowned for its distinctive triangular shape, it was one of the tallest buildings in the city at the time of its construction. There was great skepticism about its stability. People thought it was going to fall over, but it stood the test of time and continues to be a celebrated landmark in the heart of Manhattan. Originally was named the Fuller Building after the Fuller Company. Flatiron was a coined name, and it stuck with it after it supplanted the Fuller Company's name. The Fuller Company sold the building in 1925 and it was designated a New York City landmark in 1965. There are not a great picture, but you'll see things. These are awnings coming off the building, which were part of the building, basically cloth awnings that were a form of sunscreen that was used back in the day. We had the same thing at the Plaza Hotel, which is similar era, same sun control device. Alexei will talk about the metal rods that are still rotting in place, you know, all these years later. Sorry. The address is 175 Fifth Avenue. It stands between 22nd and 23rd Street. The architect was Daniel Burnham. Daniel Burnham was a New York architect, designed the Flatiron Building, and then for whatever reason moved to Chicago and became more renowned for the Chicago school style of architecture. The building's 21 stories plus penthouse, and there's 460 total linear feet of street facades on all sides. So there are lots of building materials in the building. The first 3 floors are limestone plinth courses. Whoops, sorry, I keep mixing up the advance and the pointer, so I apologize. Okay. So the first 3 floors are limestone plinth. Floors 4 through 16, terracotta ornamentation. You just see all this marvelous terracotta around here. There's brick, terracotta, plinths and lintels, all stonework, decorative stonework that Alexei will get into in a few slides. Floors 4 through 16 are terracotta ornamentation in the form of window lintel sills, jambs, plus spandrel medallions, keystone water tables, plus brick masonry. I don't think the brick really reads when you see it. It's mostly looks like a stone building, but there is a tremendous amount of brick on the building. Just a magnificent building. You could see, you know, there's a vantage point that you don't really get to see up close, and we'll have more slides, but the ornamentation and the detail and the arches are really spectacular. There's on floors 17 through 21, terracotta ornamentation and cornice. Most of you know in this audience, but terracotta, which I'll explain later, but all of you who have gone to camp or arts and crafts classes and made a clay pot, that's basically terracotta, except this has a glaze on it. It is a very fragile material. It was cheap at the time to recreate ornamentation which was very popular back in the day. As a building material, I don't know how to say this delicately, it should have only, you know, its life cycle is really 20, 30, 40 years in a freeze-thaw environment. You know, this is 70, 80 years, and all the terracotta in the city has weathered, aged, deteriorated, and in fact, the building department, for the architects here and engineers who know, about 3 years ago or 5 years ago, the building department basically declared all terracotta in failure. Not it's going to fail or it should fail, it is in failure. And architects and engineers, you prove to me, the building department, that it's not in failure and you could keep it. Otherwise, it has to be replaced. And they really disallowed patching that had been going on. I was doing it for 20, 30 years. Pinning they didn't like either. And that is why this last cycle of facade restoration has gone on so long and is so expensive to buildings, because basically we have been forced to replace much of the terracotta that is on existing buildings. For good reasons, proper reasons, but it has created a backlog since there are only 2 manufacturers in the entire United States that make replacement terracotta. So this is a beautiful photograph that you don't get to see. We actually went to the roof of a building across the street to see this, but again here on the first floors of the limestone plinths, then you have floors 4 through 16 with terracotta ornamentation. 17 through this area here is terracotta ornamentation and a cornice. There's on floor 22, there's GFRC and brick pier balustrades and a stucco penthouse and aluminum frame double hung windows throughout. We dug this up, and when I first saw it, I thought we were back in Europe or something, but Alexei told me this did exist a brief time, and the Landmark Preservation Commission finds that the Flatiron Building had, it was designated a landmark in 1966. Also, I wanted to mention, although it's iconic and very New York and international, it was Edward Steichen's photograph in 1918 or 19. He photographed it for the New Yorkers from Madison Park, looking that way through trees. And I think it was raining or snowing, and it was colorized, but this was 1909 or 1919. And it gave the Flatiron Building a global iconic audience at that time. So the Landmark Preservation Commission in 1966 found that the Flatiron Building had a special character, special historic and aesthetic interest and value as part of the development, heritage, and cultural characteristics of New York City. The Commission further found that among the important qualities, the Flatiron Building is an interesting example of the early steel-framed skyscraper built on an unusual triangular site that, due to the prow-like effect of its northern end, it creates an impression of great slenderness and height, that it displays a wealth of ornamentation, detail representative of its time, and that although a utilitarian office building, it has inspired literary outpourings of an almost poetic quality. It's interesting, when it was built, they thought it was going to fall over. Now, all of a sudden, you know, they used the site well, so history was kind to this building. You said they knocked this down like 6 years later?
Yeah. Yep.
So Throughout its existence, over 120 years, the Flatiron Building has remained an office building. Early tenants were the Equitable Life Assurance Society and the Imperial Russian Consulate. You're looking at a person in an office in the prow of the building looking north. In 1945, the building was valued at $1.05 million and was managed by Helmsley Spear. Major tenants at the point were Macmillan Publishers, who remained actually in the building until 2019. In 1991, a facade restoration program was undertaken, and by 1997, Newmark and Company bought out Helmsley and conducted further upgrades and improvements. In 2023, the building went into auction and was sold for $161 million, owned in partnership with GFP, Brodsky, and Sergente, with plans to convert it to residences. I'm sure many of you read about that in the newspapers. So here is a beautiful shot. I think that person is in the audience hanging from the rope. It's just a beautiful picture, and we use it a lot because it just expresses a lot of the ornamentation and some of the work we do. So facade inspection program, acronym is FISP. The City of New York Facade Inspection and Safety Program, FISP, formerly known as Local Law 1198. For the older people in the crowd, formerly known as Local Law 10 of 1980, requires that owners of buildings greater than 6 stories must inspect their exterior walls and appurtenances periodically. Close-up inspections have to occur every 60 feet of a public-facing facade under the purview of a qualified exterior wall inspector, acronym QE, followed by an acceptable report to the New York City Department of Buildings within the building's allocated time frame every 5 years. In 2018, the Flatiron Building was inspected and deemed to be unsafe for Cycle 8, the most severe category for facade inspections requiring a sidewalk shed and paving the way for a restoration program. Interesting sidebar, in 2017, our client GFP at the time needed us to inspect the building. Conventional rigging, swing stage scaffolding was priced to do it, I don't know if 360 degrees applies, but around the whole thing, was at the time $160,000 to rig it, and it was about 8 to 10 weeks to get permits. We came up with the idea to inspect the building by rope access. I think we did it, and I have fact verifiers here from my office that'll correct me, but it was 4 people in 5 days or 5 people in 4 days. But it was $40,000. We did it within a week, and we saved the client $120,000. So that was they really appreciated how we went overboard for them. And I don't want to say we were rewarded with the project, but it ingratiated us to our client. So now that we had all this information from the rappelling down and putting together a scope of work, it was quite an undertaking. The FISP report findings were combined with additional close-up inspections done from the building via rope access and from street facade with telephoto lens, which found the following: cracks and spalls in terracotta, limestone, and GFRC ornamentation, spalled brick masonry, and failed or failing previous patchwork that was done in previous cycles, which we will show you all of that. Understanding the material is always very important. Knowing your patient is very important. Borrowed from Italian terra, which means earth, and cotta, is baked, utilized for construction by ancient Greeks, Egyptians, Romans, Chinese in Indus Valley, and Native American cultures. Modern usage for facade cladding came into fashion in the late 19th century as a reaction to the 1871 Chicago fire, which spurred great interest in fireproofing materials. From 1870 to 1930s, prominent architects, including Daniel Burnham, appreciated the characteristics of terracotta as its lightweight, moldable, mass-produced, had the ability to mimic costlier natural stones details from hand-carved limestone, marble, or granite. So the understanding is they use, back in the old day, they used to use wood for ornamentation. That got replaced when metal tools and the ability to carve stone came into effect. Stone was used. That became more costly over time, and they came up with this idea of using terracotta as a cheaper way of recreating beautiful details in a more cost-effective manner. Although they say it's lightweight, you try to lift one of these things, it's not so light. Understanding the material is very important in our business. Terracotta itself is typically not the actual cause of the problem. We could go into a whole other discussion, which I won't, but you could leave terracotta by itself for years and it'll be perfectly okay. As in with any material, once you would introduce another material to either help, support, anchor, or complement, two dissimilar materials always create problems. And steel was used as a means of holding it together, supporting it, and it rots and rusts and puts stress and strain on adjacent materials. Instead of the iron or steel support structure hidden behind and within the units that have deteriorated due to decades of water infiltration from masonry, joints, and deferred maintenance. As iron or steel rusts, the members concurrently expand and weaken, causing a variety of pressure and loads on the softer terracotta immediately adjacent. Steel has a phenomenal ability. When steel rusts, it expands, and like slate does also, but it expands and exerts, in its expansion, it exerts tremendous pressure that is more powerful than the ability of the stone material, and that's what causes the failure. The steel is actually pushing on the stone, and it just overcomes it. And that phenomenon is called rust jacking. These loads create hairline cracks that after each freeze-thaw cycle continue to deteriorate exponentially, eventually leading to spalls which fall off the facade and land on the street or other building surfaces below. What starts out as a hairline crack, freeze-thaw, water gets into a slight crack, it expands when it ices up, it contracts, it pushes a little further in on the next freeze-thaw cycle, and eventually works its way through the materials, and that's when it attacks the steel. And this is, 30, 50 years of drip, 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 drip. So classic deterioration here, you have cracks. Whoops, sorry, did it again, wait, apologize. So you have hairline cracks. So the idea is that that piece, this triangular piece, theoretically will eventually dislodge, slide off this ledge, as these will, and those are deemed hazardous conditions. Here are previous patches or sealants that have given way and are in failure. see all this crack, all of these are conduits for water to come in and penetrate slightly one year, penetrate further the next year, and over the course of 5 or 10 years, it really gets in, penetrates the surface into the steel below. Here are previous patches that are failing. These are previous patches that are failing. So, you know, these are really unsafe conditions. I don't think you need to be an architect or an engineer to figure out that this thing one day is just going to fall off in a freeze-thaw cycle. And here is, what happens here is water penetrates through these mortar joints, which are porous. Even if the brick is glazed or more waterproof than not, the mortar joints are porous and serve as a conduit for moisture to get in. The moisture gets in, freeze-thaw, freezes in, it expands, and it pops the surfaces of the brickwork. That's why the popular white glazed brick of the late 50s, early 60s, I always say some dumb architect thought about the idea of self-cleaning buildings, but I don't know if that's a true story. But anyway, they came up with this glazed brick, which looked pretty, cleaned, not, you know, held its cleanliness a long time. But again, water got behind the glaze after 20 or 30 years, weakened everything, freezes, and the glaze pops off, and all of a sudden, you're getting shards of white glaze surface falling to the ground and can be very injurious. We have been on many setbacks, backyards, where the entire backyard is covered in these shards, and, you know, thank God it's not on the street. So here you could see, again, previous patchwork, cracks. You know, again, the idea from the building department, this triangular piece, one day when it just loses all its adhesion, will fall off and slide down and become a projectile. This is a previous patch. I don't know what they were thinking or what they did, but my grandson in arts and crafts does a better job than that. Again, more typical, and this is just to show you how, whoops, sorry. Here we go. This is to show you how frail, you know, this joint was caulked. This is a caulking joint that theoretically is to hold out the water, but I guess it was put too late in because water had already penetrated. And again, this piece is gonna fall off. Forgot whose foot this is, but you know, here are previous patches, and you could just see the openness when you think about, you know, water penetrating and causing damage. All of these joints, and there are hundreds of thousands of linear feet of joints, are all open conduits to any building, let alone a historic and fragile building, to allow water to get in to deteriorate the anchorage and the steel. So after we diagnosed all the conditions that I just showed you, did probes, construction documents had to be created. We did the inspections, completed them in 2019. Work then began on the construction documents, set forth the details and requirements for the project, and included specifications and construction drawings that established the quality level of materials, quantitatively, qualitatively, and systems required for the project. There were 134 pages, including 50 line items in the bid breakdown, no scope for windows or storefronts. As a sidebar, we produced 134 pages. A couple of months ago, I had the wonderful opportunity to go to the TWA Hotel at JFK, and they have an exhibit there. That whole building, they say in the display, was done in 60 drawings, no AutoCAD, no computers, and we have 134 drawings here. Upon completion of the CDs, the project was filed with LPC and DOB and competitively bid out in the spring of 2019, and ultimately being awarded to AWR Group. Here is a sample of some of, this is just a minuscule snapshot of one of many, many drawings that were necessary to figure out all these details, how things go together. It's really a jigsaw puzzle that had to be deconstructed and figured out, and Alexei Tajzler was the person who figured it out.
Thank you, Howard. Hello, everybody, and thank you to the General Society for inviting us here today. My name is Alexei Tajzler. I am an architect. I'm a director. I worked for Howard for over 15 years. And while the Flatiron Building is not the oldest structure I've had the great privilege to help restore, it's certainly the most famous. So we can get on to implementing the scope and mobilization. So we had the CDs, we had the bids, the permits, AWR was ready to go. What does that entail exactly? So first thing was to the installation of a full height pipe scaffolding plus additional suspended scaffolding. And you can see a great photograph of the pipe scaffolding, not unlike what we're sitting underneath right now. We then divided the building into a grid of individually focused areas, which I'll get to in the next slide. There was coordination of 15 employees at HLZAE across all levels and specialties, including architectural, structural, and special inspections. With the pipe scaffolding and the suspended scaffolding, we now could fully inspect the entire facade up close. So we found further areas that weren't visible from the rope access or from the street inspections. And then we developed a field office on site with AWR Group and Glidey McBean, who is a terracotta vendor. So the grid. So we took each facade and we overlaid a grid of 400 individual areas, about 12 by 30 feet. And what that allowed us to do was to walk the building and then individually focus on those spots, tag them with work categories that were geo-tracked, work categories such as crack repair, unit replacement, et cetera. All told, we're looking at 7,155 tags to be called out, which included over 2,000 ceramic terracotta units to be replaced, 20,000 linear feet of masonry joints to be repointed. As Howard mentioned, that is the conduit to get water to get into the backup, and 1,000 linear feet of crack repair. And you can see here, all the grid, we have about 22 rows and 6 or 1 column, depending on the facade. Here's the pipe scaffolding. This is a view from 5th Avenue, the west facade. I like to joke that pipe scaffolding is the equivalent of an adult jungle gym. You can see here, some areas are much easier to get to than others. And then on other facades, we use suspended scaffolding. In the industry, we call these drops. On the right is Rob. I took that photograph actually right as I was calling him to make sure that he didn't send me straight to voicemail. And for the record, he did answer it, so great job, Rob. He's here in the audience. So as we're on the building, we have the ability to sound using a hammer. It's a rubber mallet hammer. It allows us to hit stones that we are concerned about. We register what sound we hear back, and also sometimes the stones shift on us when we hit them with a hammer. So that usually indicates there is much further damage beyond the superficial cracks that we can see. On the right is an area, a very large probe that allows us to take a look at the backup, at the steel reinforcement. Even for a building like the Flatiron, we usually don't have the original drawings. So we have to figure out things in real time. Even if you have the original drawings, it's been 120 years since the building has been built. They've done previous repairs before. We don't have those drawings either. So a lot of times we're figuring out things on the fly. So here's me kind of staring and really questioning what I'm looking at. The pipe scaffolding goes from the street, but it does not go on the roof. So when we get out outside for the balustrades, we have to tie back in with a harness like Christy is on the left there. And then on the right, Yuri is getting very up close and personal with one of the lion's heads. You know, you got to do what you got to do, but he actually looks quite relaxed there. That lion's head in particular had to come out, so we have a sitting in our field office there on the right. But I like to talk about how do you replace terracotta in New York City. So in a typical facade restoration for historic buildings, existing terracotta can be replaced with replacement materials. Those are most commonly architectural precast, glass fiber reinforced concrete, GFRC, or fiberglass. This is in part, as Howard mentioned, there's only 2 vendors left domestically that has the trade skill and the knowledge to replicate historic terracotta. It used to be 30 or 40 back in the 1930s. Those 2 are Boston Valley in New York and Glady McBean in California. So despite the fact that the Flatiron Building does have terracotta above the 6th floor, LPC required that all terracotta be replaced in kind, given the special architectural and historic character of the building. So how is that done exactly? You can see here, this is a shop drawing from Glady McBean. Again, we're going back to the grid. And if you zoom in on a handful of the individual areas, you can see that every single one of the shaded stones is a stone that had to be replaced. There's no pattern to it. Some floors have very few, some floors have quite a lot, and it's quite extensive. Now, this is done as much as AWR would have loved to just quickly get this over with and take a jackhammer to this. They can't. We need these stones. They have to come out as careful as possible because we need to be able to mimic and measure and look at all aspects of the ornamentation and the depth of the stone, the web in the inside, the backup, etc. So the stones are carefully taken out bit by bit. And also in any terracotta building, while they do have steel and iron straps, the stones also support themselves, both up and down with dead loads and also side to side with lateral loads. So they have to be shored with 2x4s. In addition, we're taking out the major protection for water infiltration by taking out the stone. So now we have to waterproof the backup, which is shown in the green with the peel and stick. This is a view of our field office. We took advantage and we got one of the coveted north-facing corner offices for us. And you can see there's the lion's head, there's some material, there's shop drawings in the back there. As this building is going to residences, I like to think this is the last office that the Flatiron Building will have. And then here are some of the shop drawings, and you can just see the vast extent of ornamentation of all the different shapes and sizes. We have some stones that are more generic. We have stones that are curved. We have stones that project out. We have all types of stones, radial column stones, cantilevering stones, et cetera, et cetera. So how are these stones actually made? They are sent back to California. Glady McBean scans them and creates a plaster mold. You can see that here on the right. That allows the vendor to then hand press clay inside on all the sides and create the webs. More simpler generic stones can be mechanically extruded through a die or a mold, but regardless, it's whether it's pressed or extruded, it's dried with hot air. It's then glazed and then placed into a kiln for burning. The temperature is slowly raised between 500 and 900 degrees Celsius and can take up to 2 weeks. The cured units follow a very strict QA and QC process, including meeting ASTM specifications and standards. And the key point, due to industry backlogs, high demand, and short supply, the process can take 8 to 18 months to receive a single stone from when it was first called out for replacement. This is an issue that every building in New York City is facing, and is partly the reason why you start to see more of the replacement materials like precast, which have far shorter lead times. So while that's going on, we're still working. We have to figure out how is the stone going back in. We're not going to use the old iron straps that have rusted out. We have to come up with new technology. Today, we typically use stainless steel threaded rods. You can see a couple of them on the left. And then on the right, we're doing a pull test there. That's to 575 pounds per linear foot. I think it actually got up to 600 pounds per linear foot for a single anchor. So we're doing all that to make sure that what we're putting back is safe and secure. We're also working with the color. We have to match 120-year-old stone. It's quite difficult, We have to do as best as we can to get the texture right. So we're working again with the vendor, and we're matching it in shade, direct light, indirect light, etc. Once all these 2,000 stones start coming in, where do they go? Well, thankfully, the Flatiron Building has been vacant since 2019, so we have plenty of floors to store them. We don't have to worry about having them outside and getting damaged. And you can see they're all individually marked, tagged, and they sit and they wait to be put back in. And that is done by hand by AWR's crew. It's a very highly skilled process. These stones, as Howard mentioned, they are fragile. If you rest them on a side, they will spall. If you drop them, they will crack. And here is 3 workers putting in that single stone on the right. Here's some examples of some other replacements. This is a collar unit at one of the columns. You can see it's been patched before, and we opted to just do a full replacement of several of those stones. Another one here has some ornamentation. You can see the cracks at the upper right and left, there and there. And we went back with a new piece, and you can see how much ornamentation, detail we had to match with each and every stone. At some water tables, we've got some concave and some convex details as well. And then the ornamentation just keeps on coming. We've got some medallions, we have some rope bands, we have a lot of things that I've had to go to my old architectural books to find the terminology for. It's really a beautiful, beautiful building. Here's that lion's head in its new home. And then on the right, we have a coat of arms with a shield, and that terrace there, which is on, I believe, the 19th floor. Okay, so I like to end this with a case study about the cornice. The cornice is at the very, very top of the building. It is the cap. You can actually see there's a rope access inspector right there inspecting it. So as I mentioned, it's at the top of the building. This cornice in particular is over 2,500 stones of nine different molds, from the coping stone at the very top to the dentals at the bottom. All told, it's 6 feet tall, 467 feet wide, and cantilever is 4 feet away from the building, about 275 feet in the sky. Previous stitching repairs were done about 30 years ago, and we were given the prominence of the cornice. We were tasked to further review. So we sounded in the field, as you can see, there's an inspector right there, and we didn't like what we heard. So we had some stones taken out with the aid of a pipe scaffolding system. So this is what we found. You can see there's some shoring here to make sure that it stays in place. Stitching repairs, they repair the horizontal with mortar, and then they add additional threaded rods vertically, just like a stitch. In a human wound, this is a building wound. They are great, they are common, but they are only as good as far deep as you cut. And in this situation, the crack continues past the repair and runs its way all the way to the back. This is what we call a full depth crack, and it's quite honestly the worst thing you could find on a terracotta building. It's highlighted here in red. The reason this is a problem for this particular stone is that this stone is held into place by the steel strap here in the circle, the steel angle with the backwards L. This crack completely bypasses both of those two elements of structural reinforcement. So in effect, we have a stone this side sitting only on this tiny ledge here in yellow and being held in place by the other two stones on either side. So we're effectively relying on friction, which is not something we want to depend on for a building of this size. Clearly, given the height, clearly given the age, and again, it was previously repaired 30 years ago, the decision was made to replace all 268 of these stones on every facade. So how is that done? Again, AWR was given the very fun task of removing those stones, but not disturbing the other 2,232 within this cornice assembly. We were then challenged with developing a system that could shore and support the stones above as these stones came out. And then the two of us had to work together to figure out how do we put the new stones back in. So here are some early prototypes of the shoring system with steel plates. You can see we tried to come up with some different ideas. This original steel angle system was actually in very good shape, and so we were able to repurpose that. And we went with this design, which is a series of 1/4 inch and 3/8 inch thick steel plates that are welded to the steel system behind. And so the men of AWR had to go stone by stone, shore, take out a stone, shore, take out a stone, shore, scrape, prime, and paint the steel system, and work their way down all the facades. Now that we have that figured out, how do we put the stones back in, right? That's the next challenge. So one option we discussed was, well, we just spent all this client's time and money on coming up with a steel shoring system. Maybe we can repurpose that for the hanging of the stones. And so the idea was to drop a new vertical plate, run long threaded rods between each stone, and that would pick up the loads necessary to suspend the stones. We got one of them or two of them in the field to work, and then we started running into problems. The first and somewhat obvious one is, what do you do at the curve, right? These buildings do not, the facades don't meet at a point, it's a radial curve. A long threaded rod is not going to curve. Even if the building was entirely straight, all of these stones are slightly different when they come back. They're not exact. Not only that, the opening is not dead level. No building in New York City is dead level, dead straight. So we need to have the ability for the workers to work with slight discrepancies stone to stone. And again, a very long threaded rod does not give them that option. And then lastly, while this plate was great in terms of supporting the stones, it's actually too thick. The original design of the joint did not have a plate here, so it was a certain width, and this plate just doesn't fit. So we had to go back to the drawing board again. We then decided, why don't we utilize that steel angle system in the back and run some new threaded rods that are welded that come down, create a hook, and then we have small 8-inch wide threaded rods for each stone. That allows a lot more tolerance for the workers, and they can go stone by stone by stone. Here is a mock-up of it, and we got it to work. Again, you can see the angle system and the threaded rod coming down, hooking, grabbing onto this threaded rod, which sits in non-shrink grout, and then it's caulked to stop water from getting in. And that was great. We got it to work. We're all happy about it. Then we ran into the issue of the workers. The workers, you can see this is very labor intensive. There are 4 men working on one stone. It's very heavy. It's above eye level. And the men cannot put the stones dead straight back in. They need to be able to come in at an angle so they can run these bars in. And unfortunately, our coveted steel support system is now in the way. So we had to go back to the drawing board once more, because while we could take it out and put it back in, we now only have access to one side. So that means half the welds, and that means half the strength. And that was not acceptable, so we did another design. So now we no longer have the 45, we have a vertical piece. This allows a lot more points of access for welding, and that is the final stone anchor detail, which you can see on my date was figured out in November of last year. So, as of today, we have about 50 of these stones in. They are going in along 5th Avenue. We'll then move on to 22nd Street and then finish up on Broadway. Still have a few issues though. Going back, what do we do with these curves? And not only do we have all these stones coming out, but we also have other stones in the cornice assembly. We call these planter boxes, but these are very large projecting stones that are held in by this eye bolt system and rod. How do we put those back in, and how do we fix the curves? And the answer to that is, I will get back to you. Because I do not know the answer. This is an ongoing project, but we'll eventually figure it out. So thank you to everybody, and I appreciate you coming out.
Howard and Alexei, thank you so much. What a tremendous amount of work and skill has gone into this. Anyway, it was a fascinating presentation. I'm going to say more at the end, but I would now like to take some questions from our audience, and I see someone's already ready with their question. I also want to remind our online audience that you can submit questions through the Q&A option, and they will be passed to me. So here is our first question.
Hi, Howard. Eileen.
Hi, Eileen.
You mentioned a penthouse story that I didn't forget about.
Oh, no, I told
Question?
I told it about the rigging, because the penthouse that nobody could see from the ground, but you only see from up above, prevents you from doing conventional rigging to inspect the building, and that's why it was $160,000, because the penthouse was in the way of getting the rigs up there. So the rope access was a cheaper and more efficient and quicker way. I'm sorry if I wasn't as clear as I should have been.
Okay, our next question.
To Alexei.
Yes.
The hang on the cornice with the rope by the inspector, how old is that technique and that style? I have never seen it before.
It's fairly recent. We actually have Carolyn Cast here who could give you a date, but our firm started doing it, I want to say 2016? 2017. So it's very recent.
It was our idea to get us into it.
Yes.
About the
Oh, they go through a whole very strict, Yeah, it's effectively supplemented all of the drop scaffolding because it's so much cheaper and so much faster as well.
Okay.
That was just a fascinating presentation, and also I appreciate the fact that you made it very accessible. I had a question about the modern production of terracotta as well as the steel infrastructure. Has anything evolved in terms of the long-term durability with these materials that you're replacing with?
That's a great question. I would say the materials themselves, terracotta hasn't really changed. I don't know how you make it any better. It's really the anchorage system. So we're going back with stainless steel, which is an alloy. It lasts far longer than original steel straps. When these buildings of this era were going up, we did not have waterproofing membranes. We didn't have waterproof technology. Maybe at best they painted the steel, but that's all we're depending on. So now the same stones are going back in, but we're being a lot smarter about how they're being anchored.
Right. Okay, an online question. I have a feeling this might be from a friend or colleague. Alexei. Alexei and Katie, do you get an apartment when the building is complete?
Yes, I asked that question to our client, and he's like, yeah, sure, just cut me a check for $30 million.
Okay, as I move my way back, presumably this has been a very expensive construction, restoration.
Yes.
Right. Okay, this is from Marlene. If the terracotta material by the two remaining suppliers was no longer available, is there a backup material under consideration? I do think you touched upon that.
Yes, so architectural precast is the most common one. The problem with that, though, is it is heavier than terracotta. So oftentimes, if you put that in a terracotta building, now that stone is going to cause the other stones below to crack. But we didn't have that option because landmarks did not allow us to have that option. There is another company in England getting started that will start making architectural terracotta as well, but you have to ship it across the ocean. So most people stick with the domestic suppliers.
Hi. Excellent presentation. I have so many questions about beauty and design, but I have one particular one about something that's more practical. Each time you presented, you said you found another, let's say, problem, challenge. How do you budget for that? How do you tell the client and go back, we need another X dollars, when you can't anticipate those things? What's the financial structure and how that works?
That's a great question. We thankfully have a very patient and forgiving client. They understood the building that they purchased. Typically with construction administration, it's a percentage of the fee. So while this is complicated, we do have all in-house structural engineers. So I did kind of elaborate it, but all of that took over the course of a couple weeks. The Flatiron Building has been worked on since 2019, so a couple of course of weeks of additional engineering is a small amount of the actual scope of work.
But any form of restoration, whether you're remodeling an existing single-family house or, you know, a major landmark, you're bound to find hidden conditions, and the hidden conditions are proportional in cost and complexity. We do this enough to hopefully make educated guesses from 40 years of doing this. It's still an imperfect science, but we do know how to anticipate to a certain degree.
You mentioned that the repairs were geotagged. Can you explain this? Did you use a specific software, or are these repairs just on a PDF and then individually updated as repairs happen?
Great question. So we use PlanGrid for this, and PlanGrid goes to the cloud. So the employees are on the field with iPads. They take a picture of a bad piece of terracotta, they mark it as a bad piece of terracotta, it immediately gets sent to the cloud. So then we have that in perpetuity. We can share that with a contractor, we can share it with the client, and we can go back to it any time. It's very, very helpful, especially on a building this large, to remember where was that one brick that was broken. Oh, there it is.
Excuse me. So I think the key question for me is, having been through this in my own building, how much is this going to cost, or how much did it cost so far, and what will it cost when it's all done?
This is quite an expensive project. It's definitely, most co-ops do not even come close to the cost of the Flatiron Building.
So you're not going to tell us?
Thank you for a great presentation. I have a question about the shield at the very top with the two figures.
Yes.
Did you have to do any work there? And what exactly are those figures? Because they're very hard to see from street level.
Yes, I know. I don't have a photograph. I know exactly what we're talking about. It's on the north aspect of the building. It's a big shield, and there's two, I think, female figures standing on either side flanking it. That was put up, I believe, in 2001. And it's still there. It actually is in pretty good shape. I was just looking at it a couple weeks ago. So it'll remain. But what it is, maybe it's the seal of the state of New York. I don't know exactly what it is.
I'll just say, actually, just as a follow-up to that comment or question, I worked at the Landmarks Preservation Commission, and one of my special desk assignments was the Flatiron Building. And in fact, that heraldic shield with two putti, very large, sort of angel-like figures on either side, that are male, the original ones were actually removed. Someone decided that they needed to be thrown away. And so the Landmarks Commission issued a violation. And the Flatiron ownership at the time said, okay, we need to figure out how to rebuild them. And so they actually used scaled drawings that were based on historic photographs to recreate what was missing. So
Great,
I wrote the permits for that. Yes, thank you.
Excellent. Thanks so much.
Okay, I'm going to take an online question, then a question at the front, and then I will take some more questions at the back of the room, if you two gentlemen would be willing to answer more questions.
Sure.
Oh, and the online question is, was your firm able to get access to the original drawings from Daniel Burnham and Roots?
So we have some original structural drawings, and we have a handful, but we do not have all of them, unfortunately.
Yes. Just one's a curiosity question in terms of the architects who take on the rope access investigation, and are they in their times of hobbies? Are you mountain climbing or
Just nuts.
adrenaline junkies?
Karen, why don't you explain about the rope access and the people in our office? Come on. I can't embarrass you. Who can I?
I can bring the mic to you, but you can go up if you'd like. Okay.
Hi. I was not expecting this, but okay. Yeah, so rope access
sure you're in the frame.
basically. Oh, okay. Rope access basically, while it seems very crazy, it is actually very safe. I've been doing it since 2017, so 7 years, I guess now. And again, the most I've ever been injured is like a little bruise or a scrape or something, nothing bad. But it is very efficient, very cost-effective, especially since the FISP rule has changed and we have to do a lot more inspections. So we currently, in our office, and some other of our inspectors are here, not the ones on the Flatiron at the time, but we currently have about 15 rope access inspectors in our office. So it is, it's very useful. And one of the best things about it also is because it's more flexible than scaffolding, because scaffolding takes a long time to set up and move and things like that. If we see something 10 feet away that we can't like confirm is loose or safe or whatever, we could just move the ropes over and go for it. But yeah, other than that, no, I don't. I mean, I've wall rock climbed and things like that, but I'd rather rappel down a building. Any other questions about that? Okay. Oh, wait. No, there's no chair. I mean, that we kind of have like a support seat, but no, it's not Bozeman. It's just on ropes, basically going back and down.
Bozeman's chairs are not legal.
Yes. Who originated it? It's international, so I know that in New York City, it's been done for over 40 years, but it was mostly like flagpole, repairs and, to get to, get to radio towers and bridges in difficult areas, but now it's becoming more and more popular for the facade inspections.
It really had to do with the triangular shape and the effect of weather and rain and its location, and how did that contribute to the deterioration?
Yes, absolutely. The Flatiron Building doesn't have any natural protection from any of its neighbors. It's all by itself. So it's certainly, every time the storms come, typically from the southwest, work their way northeast, the building gets hammered.
I just wondered how this project compared with the renovation for the Woolworth Building. I mean, isn't that old terracotta?
That is, yeah, that was done by Slice. I actually worked with them on another building at 108 Leonard. We didn't work on the Woolworth Building, but I know that one is also got converted to residences. I think it's also still office, if I remember correctly, but this will be entirely residences. However, we had been on the building for several years before the decision was made to convert to residences. In all honesty, it doesn't really affect us. I like to joke, we're outside dogs. We stay on the outside of the building. What happens on the inside, somebody else's business.
Okay, thank you.
Okay, I will take a couple more questions towards the back of the room or middle of the room. But as I'm walking back, can I ask, did Stanford White do some of the decoration and ornamentation? And this is from online, Shoshana.
Not that we know.
I don't think so, yeah.
Okay, well, that was a quick response.
They were, I mean, they did, they were basically contemporaries, and Stanford White also did terracotta as well.
Thank you. Two quick questions. Is there any kind of 3D printing that can be done here?
So that's called microcotta. That's basically a plastic composite. That is starting to get more and more popular, but it wouldn't have been an acceptable replacement per landmarks.
Okay, thanks. And the other thing is relating to the curve that you guys are still working on and trying to figure out, would it be possible to use cables, sort of like the Brooklyn Bridge cables are intertwined, and that would be flexible?
It's not a bad idea, actually.
Hi, thank you. Good evening. My name is Jonathan Barron. I'm an interior designer here in New York City. And Alexei, thank you so much for the service that you provided here. And Howard, Thank you so much for the contribution. I want to acknowledge you for the services that you've provided New York City. It's been really amazing to watch all the buildings you've done around town. Thank you.
Thank you.
Okay, I will take a couple more. Okay, three. I'll take three more questions here, and I have two online questions, and then that will be it, okay?
Thank you. I gather that the reason you can't use lighter weight synthetic material, some sort of plastic, which you can't tell the difference on the cornice from the ground, is that a prohibition from the landmarks people?
So any type of replacement material, whether it's precast or microcotta or fiberglass, it has a different sheen to it, especially right after a rain. You can walk through New York City and you can look at buildings that have had work done, and it holds the water temporarily different. It kind of creates a polka dot effect. I would say with more and more buildings falling apart, especially terracotta buildings, it's only a matter of time that maybe landmarks loosens their restrictions. The 6th floor rule was in direct response to the DOB effectively declaring a war on terracotta. Landmarks obviously took offense to that and created the 6th floor rule. Over 6 floors is also coincidentally the height for all buildings that have to be inspected by FISP. So that story requirement was not a mistake by landmarks.
But you can't get the same quality and clarity in plastic as you can in terracotta. Well, if it's on the 18th floor, that's what I'm thinking you wouldn't notice.
No, I've definitely used other materials in New York City, and I drag my wife around town and I point out and I ask her, can you see which one's a replacement? And she isn't really interested, but just feigns like, no, it looks all great. So.
Hi, thank you. That was very interesting. I have two short questions, and if I came a little bit late, you may have said that already. How many apartments are there going to be? And I'm in the tour and travel business, and we learned somewhere that building is a copy of a building in Toronto. Is this true? And if it's that building in Toronto, that building in Toronto is nothing. It's just that it's a small building and it has that rounded corner. But is that true? Thank you.
I think I've seen a photograph of that Toronto building. I mean, if it's before 1902, then I guess the Flatiron Building is a copy. In terms of the apartments, we're not involved in that, but based on the floor plan, I would have to guess either 1 to 3 max per floor. 21 plus the penthouse.
Thank you. Quick question. I'm an architect in North Carolina, but to what extent did drone and LiDAR technology help you map this? Is there 3D mapping without the ropes, and the ropes were like a follow-up investigation?
So we have used drones before. We did not use it for the Flatiron Building. The city is starting to soften its approach to drones. They have kind of concerns of these things flying above millions of people every day, inches away from a facade. So for this building, we haven't used drones, but we have used drones on other buildings, and it's a great resource and really allows you to kind of sit in a chair and zoom in and out on tiny little elements back and forth, back and forth. So it's definitely the future.
A couple of years later after this, we have used drones to map out the Plaza Hotel, the elevations, which we are using for mapping purposes. And haven't announced this, but we got the building department to approve drone photographs as our working drawings and approved drawings. So that's a big step in accuracy, cost savings, and time saving.
Thank you. My name is Joan Gurna, and I have two very short questions. In the terracotta, because you had such an extensive replacement, were you able to use the two different companies, the one in Boston and the one in California, or did you stick with one?
In this case, we just stuck with one. Okay. Yeah, but they both have the same lead times. Right. You know, you're dealing with the same situation.
Okay. And then the other question is...
Sorry, that would be a disaster for us. It's like having two different paint companies. You know, it's just slight, even if the specifications are the same, the registry and all the specifics would be off slightly. The tolerances would be different. So what you may think you might make up in time conceptually, you would pay for an aggravation of things not coming from a single source. In restoration, single source supply is very important.
Thank you. And the last question is, were the windows replaced at any time before, since they were so early in the 1900s?
Yes, I don't know when the windows were I would say probably in the 90s, I think when Newmark took over the building, they did a window replacement job.
Right, I know we had many more questions, and I'm sorry for the in-person audience if I did not get to you, but hopefully Howard and Alexei will be joining us for a glass of wine, and you'll have an opportunity to ask those questions then. So this will be the final question of the night, and it's online. Did you need to change any of the drip edge profiles, either to reduce drips in certain places or just the gutters to accommodate more water? And that's from Anne.
It's a great question. To my knowledge, we basically matched everything exactly in kind.
Fantastic. Thank you so much. Yeah, what an absolutely incredible presentation. The depth and detail you both went into, I feel like I also have a new understanding of terracotta, so thank you. Thank you very much. Anyway, it was utterly splendid, and I think we're all in awe of the work that the restoration of the Flatiron Building is going to take. But, and one final thing I'm going to say, but it's also interesting how you use many things that are still perhaps some of the systems that have been used for years, but you're also now fusing that with new technology. So thank you so much. And just to say a few concluding words is Victoria Dengel, our Executive Director.
Howard and Alexei, just brilliant. A brilliant presentation by a brilliant firm. And I'll get back to that in a second. And homage to the craftsmen who built this building, and that you keep that testament to craftsmanship, alive for all of us, for all New Yorkers, for history. And so thank you for that. And to the craftsmen today who put the building back together. And I have to say, personally, we've had great pleasure working with Howard Zimmerman's firm. And I just spotted Mossy back there. And what professionals, because our building, just have a look on the way out, the restoration of our landmark facade was conducted under the guidance of Howard Zimmerman Architects. So thank you. And we'll be working with them on a project at the rear of the building. And what a pleasure. So thank you. And to our audience and everyone at home, take your last looks at this scaffolding. Yay! After 14 months, you're going to see a beautiful skylight restored. Easton Architects was our architect on that project, and Nova Construction. And it's back to the glory of what it was 120 years ago. And we can't wait till you sit under it, under the night sky. So that should be hopefully next week, when Aurora Lampworks will be here on Monday to put in our new 6 pendant lights. So we're very excited, our dear friends at Aurora Lampworks. So thank you.
We are going to release you, our speakers and our audience, but we also want to give you a little memento of this evening, the poster. So again, I want to thank you so much. We realize how much work has gone into that presentation and really appreciate. Thank you.